Hello, my name is Renata Guizzardi and I'm going to present the work entitled Ethical Requirements for Artificial Intelligence Systems, done in collaboration with Glenda Amaral, Giancarlo Guizzardi, and John Mylopoulos. So today there are many artificial intelligence systems being developed, for instance, driverless car, diagnostic systems, autonomic weapons, and so on. And such systems, they perform the tasks that were before the responsibility of humans. And they make a lot of decisions on our behalf. Thus, it is important that AI systems, they abide with ethical principles and codes. Such codes exist for different professionals, for instance, drivers, for medical doctors, for the military. However, such codes are not considered today for the development of AI systems. And that's what we propose. We propose that ethical codes and principles, they serve as sources for deriving ethical requirements for artificial intelligence systems. And for that, we propose to use existing requirements engineering techniques. So let us review a bit about requirements engineering. RE is the activity of software engineering concerned with the capture and the analysis of the requirements of the system to be stakeholders. The system specification consists of the set of functionality that the system to be must be able to perform, some quality constraints, and some domain assumptions. The stakeholders, they include all the parties that are affected by the system to be or influence the development or operation of the system. And ethical requirements are the elements of such specification, so functions, quality constraints, and domain assumptions that are derived from ethical principles or codes. Now, going over ethical principles and codes, we have that ethical principles are general principles of conduct towards other people. We give here as an example some ethical principles that were developed by the European Union for artificial intelligence systems. For instance, there is autonomy, which is the respect for human dignity, beneficence, which means doing good to others, nonmaleficience, which means doing no harm to others, justice, treating others fairly, and explicability, which means behaving transparently towards others. So this is a set of principles that the European Union adopts that should be respected by AI systems. They are not the only set of principles that exist, but this is the one adopted in this work. Finally, ethical codes are domain-specific codes of conduct derived from ethical principles. They are, in general, developed for different professionals, so employees of an organization, medical doctors, and so on. We see ethical requirements as ecological requirements. What does that mean? Well, traditional requirements engineering often views stakeholders as being just the users of the system. But in AI systems, we need to extend this view. So not only see the users as stakeholders, but all people affected by the system. For instance, for the driverless car, stakeholders would include pedestrians, passengers, other drivers, bystanders, etc. So all people affected by the driverless car system. In this sense, ethical requirements are necessarily ecological requirements in the sense that they are derived from the whole ecosystem in which the design system is included. And from an ontological point of view, this is the case because they are derived from values and risks. And value and risk are contextual properties in the sense that they are dependent on the context for their manifestation. So now that we saw a little bit of the theory behind our work, let's see which are the steps of the proposed method. So step 1 is to identify the stakeholder types in the operation environment of the system to be. So again, we mentioned that for a driverless car, this should include passengers, pedestrians, drivers of nearby cars, bikers, etc. The second step is that for each stakeholder and for each ethical principle that we mentioned before, we should derive requirements for the system to be. For example, for the driverless car, we have a set of requirements here. The car shouldn't drive too close to a biker. This is derived from the nonmaleficience principle. The car should not send personal information about the pedestrian. This is derived from the autonomy principle and more specifically from privacy. The car should allow another car to cut in front of it. This is derived from beneficence. And the car should be able to explain what route it is going to use to get to its destination and why. Such requirement is derived from explicability. So this is not a complete set of requirements, an exhaustive set. It's just a few examples so that you understand our proposed method. So the last step, step 3, is that for each requirement identified in step 2, we should derive some ethical requirements, so some functions, some quality constraints, or some domain assumptions that are included in the specification of the system to be. So let's consider, for example, the requirement, don't drive too close to a biker. This means that the system to be should support a function that recognizes the bikers and limit the drive function to maintain a certain distance from each biker. For instance, a 0.75 meters between the car and the biker in the street. From the requirement should not send personal information about pedestrian. We should guarantee that the specification does not include any function that will send personal information to other systems. From the requirement should allow another car to cut in front of it. We understand that specification should include a recognition function for cars that are trying to cut in front of the system to be, and a function to make space for such cars. And from the last requirement we elicited, so should be able to explain to its passengers what route it is going to use to get to its destination and why. The specification shall include an explanation function so that the system can generate an explanation such as, we are taking route A because traffic on the alternative route B is moving very slowly. Or we are taking route A because it is the shortest route to the destination. So in this position paper, we propose to adopt requirements engineering techniques to build artificial intelligence systems that comply with ethical principles and codes. So the requirements are actually derived from such codes. Here we illustrate our approach with the derivation of functions and quality constraints for a driverless car. And it is important to emphasize that our solution does not render the AI system autonomous in ethical decision making. It rather results in a system that complies to ethical principles by design. In other words, we mean that such principles they are considered in the development of the system since the requirements engineering activity. As for implementing ethical requirements, the system should be able to perform any such functions as well as a human being would perform. So, recognizing a passerby, biker, or making space for another car to cut in front as any human would do. So, thank you so much for your attention, and we'll be happy to respond to any questions you might have. Please contact us.